When it comes to climate impact, reducing CO2 or reducing fuel burn is not enough. So we need to reduce other types of emissions and try to understand how the other emissions impact the climate. So this is why we brought together climate scientists and propulsion engineers to try to figure out how these technologies will impact the global warming in the future. So basically, we want to be able to bring in this knowledge already in the preliminary design phase to be able to design engines and develop engines that in the future will be more climate friendly. So the responsibility that Chalmers has on Minimal is to coordinate the project, to scientifically coordinate the project, and we're also responsible for developing one of the engine concepts, and we are also responsible for leading the work package that coordinates the heat management activities.
So thermal management is a very broad topic, but one of the key components in it is this. So this is a heat exchanger. You use it to exchange heat in between a cold and a hot medium, and I'm working on conceptual design of these. Later on, we're going to do experiments and actually look at how do we put them inside the engine and how do we reduce the losses. The main reason why we want them on the engine is because we have very cold fuel that we want to heat up, and we have a very hot core stream that we need to cool down. And we can use that synergy to make the engine core much smaller and more efficient. So heat exchangers, very, very cool components.
In traditional jet engines, around 20% of the core mass flow goes to just keeping the blade from melting. In the novel concept we're developing Minimal, the temperature and pressures are even higher, so we're pushing the numerical models to the limit. In work package 3 in Minimal, we are developing both numerical models to handle this high temperature and pressures and verifying these models in experiments such as these here at the low pressure compressor at Chalmers.
This is the engine we are developing. I think it is a really cool engine because it is a combination of a turbofan used in aircraft and a piston engine used in trucks. We are investigating this engine because it has the potential to be extremely fuel efficient and clean. Before building an actual engine, you need to perform a lot of simulations to understand how the engine behaves and how to design it in the best way. My role in this project is to develop numerical models to simulate and understand how this very complex engine works. These models will then be used as guidelines for further design steps.